Now let's just practice taking a couple definite integrals. So I want to start with one that's actually pretty simple. So let's look at the integral from 4 to 25 of 2 over the square root of x and of course dx. So this is equal to, as you know, any antiderivative. Well, even before I find a specific antiderivative, let's just take that 2 out and look at this as integral from 4 to 25, 1 upon the square root of x dx. And we know we can use the power rules and come up with an antiderivative of 1 upon the square root of x. That's like x to the negative 1/2. And so I can write 2, and in this set of brackets I'm going to put my antiderivative, which would be x negative 1/2 plus 1 would be 1/2, and then divided by 1/2, which of course is the same as multiplying by 2, but I will write that as divided by 1/2 for right now. All right, so inside the square brackets would be the antiderivative. This will become the definite integral if I'll evaluate that at the lower and at the upper limits of integration. So almost done. So I've got a 2 divided by 1/2 would be 2 times 2 would be a 4. And then what do I get when I evaluate? All that's left here is the square root of x. Evaluate that at 25. Square root of 25 is 5, minus what I get when I evaluate at the lower limit of integration. So this would be the square root of 4, would be 2, would be 4 times 3, would be 12. And so my definite integral is a number in this case. It's equal to 12. And had we have drawn this function, 12 would be the area under the graph of this function between 4 and 25. Okay. All right, I've cleared the screen and I've written down the next example. And I went ahead and wrote it before I started talking about it because it's a little more complicated in appearance. But the first thing to do is to think about finding an antiderivative for the integrand, an antiderivative for log t raised to the power 2 divided by t. And I know that we've recently worked a problem almost identical to this, and we used integration by substitution. So let's try a substitution. I want to get yellow here for my substitution. So I encourage you to be complete whenever you do substitution. It just helps for others to understand what you're doing, and it helps when you come back later to look over your work. So why don't we let u equal, and you remember that this is an educated guess, but I'm looking here and I see that I've got an inner function log t to a second power. So I think I'm going to let u be the natural log of t. Now that was my choice. I think that will work. But once I choose that, the du is fixed. The du has got to go with what I've done for u. So if u is log t, the du would be 1 upon t dt. And now when I look at my integral, the integrand, I've got a factor of 1 upon t, and I've got a log t. All of this looks pretty good. I could even, if I wanted to, I could even rewrite this one more time. Integral e squared. Now instead of log t, this would be a u to the second power. And then I've got a 1 upon t and a dt. 1 upon t dt is d du. So I think we're in pretty good shape here and should be able to complete this problem without much trouble at all. We'll change here to kind of a hot pink, and I will write And I'm not going to worry about these limits right this instant. I know that they're there, but what I'm going to put inside the bracket is I'm going to put in the value of the indefinite integral u squared du, which would be u cubed over 3, and then that would be evaluated between e and e squared. Now there's something going on here, because here my variable is u, but these limits were limits on t. So I cannot evaluate at these limits right here, but what I can do is go back to the original variable. I can do back substitution, and when I do that, then I can evaluate at these limits. And so let's go ahead and do my back substitution. And when I do back substitution, in place of u, I'm going to have the natural log of t, and I see that that's cubed, and also divided by 3. Now that is in the original variable t, and that is where the limits e and e squared apply. So now I'm going to do the substitution, make life easy for us. I think I'll just take this 1/3 out, so we'll call that 1/3. Now what am I going to get here? I'm going to get the natural log of e squared, and then all of that cubed, minus the natural log of e, and then that has to be cubed like that. So they're substituting. Now let's think about the powers of logarithms here and what we know and how they work. The log of e squared, so this is just kind of an aside, would be 2 natural log e, and the natural log of e would be 1, so this would just be 2. So here I've got 2 cubed, and here I've got the natural log of e, that's just 1, and 1 cubed is 1. So let me write that this is equal to 1/3, and 2 cubed is 8, and 1 cubed is 1, equals, we're inside of a final answer now, 8 minus 1 is 7, times 1/3 is 7/3. And so that's our second problem. Definite integral was evaluated using a substitution method that we've learned earlier. Everything we've learned before still applies. Thank you.